Alright, now this is going to be an interesting segment. It's going to be towards all our local ones because our friends in the US got the D16Y8, which is a proper VTEC. However, locally, all we get is VTI, that's P2j core. But it's basically a D16Y7 or Y5. However, locally, what they do is adapt a P08 or D16Z6 cam and rocker arm assembly into a P2J head. We're gonna talk about the problems and issues that it would have on the cam timing and the dyno, what we did a few years ago for log file tuning or LFT Austria. And we'll talk about some potential tuning issues so you know you don't want to miss that. Alright, now here's a P2J head that we ported years ago, and you can see we got the shape and curve all efficient, or at least shaped to be consistent to provide flow efficiency, so that it'll perform really good. Now here's a P08 head, all finished up and shaped really well. Look, that definitely is gonna flow really good and make good power. At the same time, fuel efficiency, it's just gonna be efficient and really strong. Now look at this. Notice the visible difference between the P2J and the P08 here. As you can see, the P2J curves to the right, whereas the P08 is just straight flowing, So this means the P2J head is trying to promote swirl in the combustion chamber. And we all know swirl is for economy. It gets better fuel efficiency, at least by design, that's the hope, So when you think about it, a P2J head is actually an econo head, nowhere near for performance. I mean, you don't see a B16 or B18 cylinder head that's twisted for swirl, right? Now you can see the difference. Now on the left is the swirl, and you can see on the right is tumble or stumble. And that's how our ESI, P08, or even B16 or B18 heads are. Even the K series, because the swirl is more on economy and I've yet to see a performance-oriented engine that relates to swirl. Not in the F1, MotoGP, or even the 20 valves of Toyota. Now some of you will talk about compression, right? So let's go there. This is a P08 or D16Z6 chamber. It's about 34.6 cc on chamber volume. You can see how it good, how it is, and let's compare to the Y8 or the P2J. This one has 32 cc of chamber. And yes, you can see the quench pad, right? That's what they talk about. It has more quench or more power. But when you think about it, quench distance has to be minimum 0.038 up to 0.040 or 1 millimeter. Anything more than that, it renders it useless. So when you think about it, do you get it correct? Now this is a PM3 D16A6 or ESI chamber. Look, it's actually bigger than most. It's 38 cc on chamber volume. But when you think about it, I thought ESIs produce more torque, right? That closed chamber whatever is rendered useless because you're not taking advantage of the proper quench distance because it's not allotted to. So let's go do some math. Remember I said quench distance to be ideally functional, it's gotta be 0.038 to 0.040. And you gotta understand that most of our stock pistons sit 0.020 below deck. So you gotta factor that in. And then you have your head gasket, the steel multi-layer gasket, thick as 0.032. So that's around 0.052 quench distance. So when you think about it, that's actually next to useless. So what are you guys pushing it for? And now, on to the more technical stuff. This is a VTI cam gear, and this is an ESI or P08 cam gear. Okay, now here's where people get it wrong, yet don't know they got it wrong. Now onto the VTI cam gear. You can see this part is the reference point or one of the reference points for top dead, right? Same thing with the P08 or ESI cam gear. It's up there, one of them, and then on the left and right side and all the other reference points like the 7 o'clock portion. But look at this. You can scribe a line straight down to the woodruff key or kunya or slot, and you can see the teeth of the cam gear is perfectly in line, right? Whereas to the VTI look, the keyway is slightly advanced. And when you think about it, one teeth of the cam gear is equivalent to 9 degrees. And that's like a half tooth off. So that's 4.5 degrees off. So when you think about it, what cam gear would you use for a P08 cam on the P2j head? Adjustable cam gear? Sure, but where are you gonna adjust it to? And I'm sure the expert will be going like, yeah, we can adjust that, no problem. We can do that, fine. Once you get it correct in alignment to the crankshaft and the camshaft, that they're both in top dead, here is the next problem. Our distributor isn't just responsible for ignition, it also has a CYP, CPK, and spark. So it's like it has a sensor for top dead center, which is a CPK, crankshaft positioning sensor, and then CYP, which is a cylinder positioning sensor. So when you think about it, the distributor dictates when your injectors would fire up. So yeah, you can get the cam gear correct with the camshaft, but that's correct towards the crankshaft to the bottom, not necessarily correct for the injector sequence. That is why we see a lot of VTI or P2j converted that runs either slow or just high on fuel consumption. The funny thing is, I know of a blue EG with a D15B P08 engine. His friend, a red LXI SIR body, did a PH15 or 16 with a P2j head converted with a P08 cam, dictated by the shop owner that did it for him, because the shop owner's car was the same. And guess what? It was left behind by 3 cars. That's slow. So the shop owner couldn't believe it and tried it with his car and still lost by 3 cars. What's more hilarious is that those 3 cars was tuned by the same tuner. Hello? Does everyone follow what I'm trying to say here? Like the woodruff key or kunya is perfectly aligned on the P08, right? And on the P2j or VTI is slightly off, like 4.5 degrees off. And yes, you can align it with the adjustable cam gear, but you got the adjustable cam gear timed well or advanced properly, right? But let's not forget, the camshaft also has the distributor installed to it, like this. That's the keyway, and look. So if you advance it 4.5, that's off by 4.5 on the distributor. So if you time it like 16, so it's 4.5, that's around 20 or 21. And as we showed you the diagram earlier, you can time it with the timing light, but your injector phasing would be way off. That is why you consume so much. So when you think about it, not achieving the perfect quench or distance and then not understanding injector phasing, you're doing it wrong. That's just like a 6-letter word, this. And I know you guys know that, right? And I know some of you guys have friends or Facebook experts that's gonna say that you can port the P2j to flow well, right? And I would have to agree, that's possible, yeah. But ask them this, if they can do that to the P2j head, can they port the P08 to be slower or even more faster? Of course it's gonna be faster, right? So what's up? And this is a P2j straight VTI that we ported really well, just so that it can perform really good. This VTI actually tested with that fast EG and almost got it. It still lost by 1 car at least. So imagine if it tested out with the LXI, the red one, that would have lost. So imagine that, a P2j converted head losing to a straight VTI. That's how slow it can go. So when you think about it, what happened to the combustion chamber craze, right? As I know everyone's been waiting for this. Plus, someone asked me, did I know how to set the cam gear? Like, look at this. Come on. But yeah, we did the cylinder head for the guys at Log File Tuning Austria. Here it is. Now look at that P08. Those ports look really, really nice, right? We did this in around 2017, so around 5 years ago. The consistency is right there from the throat to the bowl and to the sidewalls. It looks really clean. And we actually cleaned up the combustion chambers knowing this is gonna be a high boost turbo. So we wanted to make sure efficiency achieved in the chambers. So this is for those wondering if we know what we're talking about. You decide. And also for those who think that since you're going boost, porting is not important. Here is the stock ports. Log File Tuning did this on 1.8 bar, 400 wheel horsepower, using ID 1000 injectors. Now with our head installed, still 1.8 bar boost, look, 497 wheel horsepower. That's almost 100 horsepower gain from just the cylinder head porting alone. And guess what? They are already maxing out the ID 1000. That's crazy, right? So when you think about it, suddenly they're maxing out their ID 1000 injectors? That means more airflow. Now with ID 1650 and a Bosch fuel pump and 2.5 bar, look, 557 wheel horsepower. That is crazy. And actually, they now hold the 1 mile record in Austria. These guys are crazy, right? But that just shows you that a ported head is indeed useful even for turbos. They went from 400 to 557. That's 157 wheel horsepower gain. But going back to the P2j and the swirl port, you see why it's for economy. And one good incentive for subscribing is that we plan to talk about thermostats, cooling system, and once we get a data log, we'll show more of this. And you can see the one above with the thermostat, the coolant temperature is very consistent, right? As well as the inlet temp or the intake. And look, without the thermostat, the coolant temp is quite erratic. And even if you're running a rechipped ECU, or even a stock ECU, you know that fueling compensation happens on the ECU. And that is why you never see a good fuel consumption without the thermostat. And plus, you start burning off your head. And we're going to talk more about that in the near future. Now here's the main reason why you should subscribe and hit the bell notification. We are working on developing a proper video about velocity stacks. You can see here, it pulls air from all around it, like all around the area in ambient form. But when you put it in a forward-facing situation, look, this is probably why we saw negative pressures on the map sensor. And we tried to solve it with our idea, because even if you flush it on the bumper, look, it still avoids it, right? And you can click here to watch that velocity stack video that we did before, so you can see what we're talking about and why we're trying to improve the whole design itself. Now here's a ram air system. When it's forward facing, it's trying to get a lot more air than usual, right? And even if you flush it on the bumper, look, it's still getting in more air than a conventional velocity stack. So you gotta subscribe to watch this once we do it when we reach 1000, because we plan to continue to give even better technology sharing. And actually, we are considering pulling down my current D16A6 fully cammed and pistoned engine just for the sake of a build series for you guys. Oh, and don't worry, we will dyno every single thing that we put on the car or the engine just for you. So you gotta subscribe. just to keep track of this, right? I actually talked to my colleague about this and we agreed we might dyno a stock P08 intake manifold and then dyno a ported intake manifold and then dyno my Skunk 2 ported intake manifold just to see the differences and also to show you guys what's up and also eventually the ITB, right? So going back to the lone advantage or the thing that you guys think is an advantage, the P2j head or engine that has it runs 9.6 is to 1 compression. And the P08 or D16Z6 is 9.2 is to 1 compression. So that's just zero point 0.4 of a difference. And if you can click here on my D16A6 ESI head, we have a dyno sheet there that we lowered the compression by 0.9 and still made more power. So when you think about it, compression alone is not going to get all the great power. It has to be the whole engine dynamics of itself. It has to work together really, really well. And compression is nothing without efficiency.